This is Linear Algebra 2.2. Previous video, we studied how to define inverse metric, how we're gonna find the inverse metric of 2 by 2 metric. So this video, I'm gonna show that how we're gonna use inverse metric to solve metric equation, guys. So let's just start with theorem about solving metric equation, guys. Look at the metric equation right there, ax equal b. So we want to solve this metric equation. Before we talking about solve the metric equation, guys, you guys remember this linear equation in algebra class? Linear equation is algebra class 2 times x equal 5. So you're gonna solve this linear equation, you divide by 2, which meaning is you times 1.5, both sides. So this one is 2, 1.5, gonna be 1. 1 times x is x. That's 5 over 2. That's how to solve linear equation, right? Same thing here. A is invertible, which meaning is you're gonna say this has, you're gonna write down A has inverse metric. So you're gonna say, so A inverse, A gonna be identity matrix. That's the meaning of invertible, right? So any B vector, AX equal B, that's metric equation, has the unique solution. Unique solution X gonna be A inverse times B. So how can get there, guys? So let's use this one, guys, this equation. So you're gonna say AX equal B. So this is metric, guys. We're gonna do same process. Both sides, we're gonna times inverse matrix. So very carefully is right side, guys. Order is really matter when you're talking about inverse, the multiplication of matrix. So you have times A inverse left side. You're gonna say A inverse left side too. You're gonna times inverse matrix is right side. You're gonna put the right side. So this one is rewrite this one. Association rule is works for the multiplication of matrix. Make sense? A inverse times A. That's exactly identity matrix. Identity matrix X equal A inverse equal times B. Identity matrix is like work like the one, guys. This one is X equal A inverse B. Okay, that you solve the metric equation by using the inverse metric. Okay, let's do one example, guys. So solve the system of equation by using inverse metric this time. How many different ways solve the system of equation, guys? Row operation, vector equation, metric equation. That's what we studied previous chapter. Now, we want to using inverse metric to solve system of equation, guys. What is it gonna be? Figure it out first. This one change into the metric equation. Metric equation form is A times X equal B. A is coefficient metric, X is the variable, right? B gonna be constant. How can I write down A, guys, everyone? So A metric gonna be right here, coefficient 3, 4, 5, 6. That's the matrix A, coefficient metric. What is X gonna be? Variable x1, x2. What is B? Constant metric gonna be 3 and 7. So now, this one is a metric equation, guys. Ax equal B. So theorem say A is invertible if A is invertible. Then X gonna be A inverse B. But we have checked invertible or not. That's the key point, right? How can check invertible? Invertible meaning is determinant A gonna be cannot be 0. That's gonna be invertible, okay? So let's just start that one. So determinant A gonna be AD. This is A, B, C, D. 18 minus 20, that's the negative 2. It's not going to be 0. Oh, so we can use that theorem previous slides. So we're going to find the A inverse first, guys. A inverse is 1 of determinant A, D, A minus B minus C. So here is 1 over negative 2, D gonna be 6, minus B gonna be negative 4, minus C gonna be negative 5, A gonna be 3. That's inverse function, right? So we're gonna find X value. X gonna be, you say X gonna be A inverse B matrix, right? So before that, that's the times this scalar inside, negative 3, 2, 5 over 2, negative 3 over 2. That's inverse metric, guys. All right, let's find it. Let's find this one. So A inverse, negative 3 and 2, 5 and 2, negative 3 and 2. What is constant factor, constant metric? 3 and 7. How can do the multiplication of a metric? 3 times, negative 3 times 3, negative 9. 2 times 7 plus 14. Here is 5 over 2 times 3, 15 over 2, negative 21 over 2. Here is top is 5. Guys, right? Negative 6 over 2, negative 3. That's the solution of a system of equation. What are you going to say, guys? X1 is 5, X2 is negative 3. That's another way to solve the system of equation, guys. Let's practice to solve the system of equation with inverse metric. You can pause the video, guys, and then practice on your own. So this one is this system of equation is changed to the metric equation. Metric equation form is gonna be what, guys? A x equal b. That's the first step. What is A? A represent coefficient metric. X is variable vector. B is constant vector. Okay, so let's go. A gonna be 3, negative 1, 2, and 3. Variable x, x1, x2. Constant matrix 7 and 1. So that's you find it. So we want to use the theorem. Theorem is going to be say A if A is invertible. How do you know? Invertible meaning is determinant A cannot be 0. Then X gonna be A inverse B. So first step you have to check, guys, this case, you find the determinant A. So determinant A, how can find it? That's gonna be, let's say this is A, this is B, this is C, this is D. Let's check it. AD minus BC. AD is 9. Minus minus 2, that's the 11. Of course, that's not the 0, right? So you are saying A is invertible, which meaning is A inverse exists. So we want to find A inverse 1 over determinant A, D, 3, negative B, 1, negative C, negative 2, A is 3. So what is determinant A? That's going to be 1 over 11, 3, 1, negative 2, and 3. I'm pretty sure everyone has the same thing. Okay, now, what is you want to find the x? X going to be A inverse B. So I'm not going to scalar multiplication first, okay? I'm not going to do scalar multiplication first. So when you do the scalar multiplication, you can do later. All right, let's do the multiplication of metric first. 1 over 11. Remember that, right? First row, first column. That's gonna be 21 plus 1. Second row, first column. That's gonna be negative 14 plus 3. So you have 1 over 11, 22, negative 11, which meaning is you have 2 and negative 1. Okay, that's your find it. So x1 gonna be 2, x2 gonna be negative 1. Okay, that's the solve the system of equation by using the inverse metric. So far we learned so many different ways find solution of system of equation, guys. You have vector equation, metric equation, row operation. So every methodology you can apply when you solve system of equation. Okay, here is a property of inverse metric, guys, but I'm not gonna do formal proof of this property, but I'm gonna explain what you mean by that, guys. First, A is invertible. So A has inverse metric, then A inverse metric. Inverse of A has another inverse metric. So this is inverse of A. What is the inverse of metric? It's a little tongue twist, but inverse metric of inverse gonna be A itself. That's gonna be one property, guys, okay? Second is AB is invertible. AB times, that's the new metric after multiplication, have invertible. How can find the inverse of AB? Very easy way to find it. Inverse of B times inverse of A. That's the inverse of AB, okay? A is invertible. A has inverse metric. How can find transpose metric? Inverse of transpose, okay? How you gonna find inverse transpose? That's gonna be transpose metric. Guys, we wanna find inverse of transpose of A. That's gonna be transpose of inverse of A. That's you're gonna find it, guys. If you wanna know how to prove this property, you can look up the textbook.